The bottom two options in this window are Realtime Plain Fit and Offline Plain Fit. The Realtime Plain Fit option determines how the image will be displayed while you're taking data live, and the Offline Plain Fit determines how the data will be saved. There are the same options available for both, and we really always keep these set to the same two things, but it's important for you to understand how they work. When I have a sample and I mount it on the microscope slide with double-sided sticky tape, let's say if this is a sample, it's going to wind up being at a little bit of an angle no matter how careful I am. And so when I scan it, if I didn't do anything else, I would get an image, let's say, that was really bright in this area and really dark over here because of this tilt just from the way I've mounted it. That's not of any scientific interest at all. So what we would like to do is accumulate a whole image, have the computer look at all the data on the whole image and fit the best plane to it, and then correct for this tilt so we get a level-looking image where the changes in topography were physically meaningful. That's what it does for the offline plane fit. So that's what it does in order to save an image. It accumulates the whole image, does the plane fit, and saves it in that format. And if you wanted to, you can turn that off, but there's no reason to want to. When it's accumulating the data, it has no way of knowing what the entire plane worth of data is. And yet it's very useful for us to be able to see this image live as it's being accumulated, because much of the time you don't want to wait for the whole image to accumulate before you zoom in on some feature of interest. And so in the line plane fit option, which is what it's set to now, what it does is it accumulates one line of data as shown here in cross section. So it's I'm plotting Z on the vertical axis, X on the horizontal axis, and this might be one line of data taken across here. The computer for this one line of data finds the best fit straight line through the data and compensates for that slope to show the data being flat here. And that's what you're seeing on the screen here. So every line is adjusted to have zero average slope, and it's also every line is adjusted to have the same average value for the line. Most of the time, this gives you a very meaningful display, and in fact it's the best way to look at your data. But it does happen occasionally that, let's say I have a step in my sample where perhaps this bottom part of the sample is high and the top part of the sample is low. Because I'm doing this line by line, quote, plane fit, unquote, it's going to subtract out that average height difference, and that will be completely suppressed, that step, on the image that's displayed, although it would be present in the data that is saved to the disk. Let's look briefly at the analysis options, which are accessed by clicking on this colorful TV icon in the upper right. Here is a typical image that we have accumulated in the way that it is saved to disk, and you can see that there are a lot of different streaks horizontally. Some of that streakiness comes because as the tip is scanning along, it might pick up an extra piece of dirt, which changes the height of the tip and therefore the apparent height of the sample. And some of it comes from thermal drift in the instrument. So most of the time it is necessary to go from this type of image, which is the full plane subtracted image, to the line by line version subtracted in order to get rid of this streakiness that's associated with tip changes. In order to do that, first I have to select either the left image or the right image. And to do that, I go to Image, select Left Image, let's say if I want to look at the height image. And then in order to do the line-by-line plane fit, I click on the roller pin icon, which stands for Flatten, or I can go to Modify Flatten. Those are two equivalent operations. So I'm going to click on the rolling pin icon. The flatten order, ordinarily you want to make sure that that's set to 1, so that it will do a linear fit line by line. There are some exotic circumstances in which you'd rather fit the best fit parabola to each line or the best third order polynomial, so you can type in other things, but most of the time that should be kept at 1. And then when I hit execute, watch over here, this is the way it looked when I was accumulating it, and it's done this line by line subtraction on it. You can see, if you zoom in here, that there is a bright line right across here. That is completely an artifact of the flattening process, because I've got a high part of my sample here and a high part here, and there's a gap in between. The flatten process, which does this line by line plane fitting, adjusts every line to have the same average value, and so it's going to boost the values here so that they have the same average as the rest of the image, and that's why this appears lighter. It's also why the part, this is a contact pad structure, that also explains why this is very bright here and darker here, because there's less of the contact pad here to contribute to the average height of the line. So although this is probably the best way to display this particular image, you need to bear in mind the kind of artifacts that can arise from the flattening process. Let's look at a different image, and let me show you a different way to do flattening. So here's a different image that I want to use to illustrate one way in which we have control over that flattening or line by line subtraction process. So again, I'm going to do image, select left image, which is the height image. And now if I flatten this by clicking on the roller pin icon and then clicking execute, we get this variation that I was just talking about, where there's a band here that's bright, and that's an artifact because I have high places in my sample here and here that are changing the average height. So let me undo it by clicking on undo. If I draw boxes around these high places by clicking, letting go, then moving the mouse and clicking again, that's created a box, which probably you can't see very well on the camera. Let me draw another one over here that you can see nicely. I don't really want that one, so I'm going to clear both those boxes. So I'm going to draw boxes around the high places in the sample. So I've just drawn a box around this high place, and now I'm going to draw a box around this bottom high place. And now when I click on execute, the flatten algorithm is going to ignore those spots when it's calculating the flatten. So now, and now I'm going to click clear to get rid of the boxes. Now you don't see this artificially raised place because it wasn't thrown off in its height calculations by these high places in the sample. So very often, especially if you have a big piece of dirt, you want to draw a box around it before you do the flatten to get the best possible image. When I quit out of the flatten, let's say if I try to open a new file, it's always going to give me this warning, current file has been modified, save it, because you've done a little bit of data manipulation with the flattening. Most of the time you want to pick no, because it's pretty quick to re-flatten, so it's not worth it to save it. But if you've done a lot of effort to draw boxes around many of these little high places, then you might want to take the time to save it.